Okay, let's try this again, kiddos. I did it once already and had some crazy stuff happen and lost it. There's a little bit I'd like to fix on here, but I don't know how to fix it. So we'll just have to deal with it later. So dilations here, kids. So we start off with these terms over here. So this stuff in the gray, I'm using this little pencil icon. Actually, that's right there. That pencil icon. These means center of dilation is not slide 2 in the instruction. That's where you're going to find it. Okay? So when I look at your course structure, it looks something like this. Dilations, there's my section, there's my little section we're in, there's the subsection, I should say, similarity, right triangles, and trig. Dilations, similar figures, triangle similarity, it goes on and on. So like when I say slide 2, and I forget what it is.
Oh my gosh, I'm so excited.
That's slide 1. That's slide 2. That's slide 3. Okay? And then I also mentioned the section it's from. Like this is from the warm-up. Or instruction, or the assignment, or the summary. I'll list those out in there too, but that's where some of that information comes from. So that means slide 2 of the instruction, you're going to find the information right there. Slide 2 of the instruction, slide 2 of the warm-up for proportional reasoning, another slide 2 of the instruction. So those are ones you're going to get definitions for. I gave you the definitions for these. Image is an image after a change. Pre-image is an image before a change. Those are things you should be familiar with. Now, the instructor talked about the movie. Okay, so let's shrink this down. In fact, this is a dilation. That's a reduction. That's an enlargement. Orientation stays the same. Length stay proportional. Angles stay congruent. But I'm going to copy this. Paste it. Let's bring it up here a little bit. Let's make this one a little bit bigger. And this is basically why they call, he's calling the movie and what do you call it? A dilation. Okay. So I'm going to get this purple pen out. I'm going to get a shape in here. I need to hit this button to make it work better. And I just draw a little line in going through those corresponding vertices. Let's make sure it's long enough right there. And then I do it for the other ones. So there's one more. Let's get this last one in. Again, you want to get it right on the vertice. Go through those vertices. And notice they're all pretty much intersecting at the same spot. It might be a little bit off, but that's just because I can't be perfect on here. They get close together just because they're overlapping. But this would be like where the light is for the projector. This would be the film. And then this would be what you see on the screen. And that's basically how that works. Kind of like the hand puppets. If you've ever done the hand puppets, like in a projector lens and it looks bigger on the screen, that's what you're doing. Okay, let's move on with this. Now, cross multiplication, that's a good technique on proportions. That comes up on proportions quite a bit. So over here, here's the little rule. I got to remember to use this. I think this shows up better on the screen for you. So we're right over here. A over B equals C over D. Now when we do A over B equals C over D, that equals AD plus BC. But why do we call it cross multiplication? It's because if you look at it, I multiplied A times D. Those are along that line. I multiplied B times C. Those are along that line. I put those two lines in there, you get a cross multiplication. So slide 3 on the warm-up. They give you a proportion, and they ask you to solve it. So you should be able to turn this into this without my help. I want this purple to make my 5 look a little better. Okay, so we got 3 times 25. I want green. We got 3 times 25. And then we got 5 times a plus 5. And again, notice I have this times the parentheses. I have to multiply it times the entire statement, not just a or not just 5. We distribute. 75 equals 5a plus 25. And from there, I'm going to let you finish up solving that one for slide 3 on the warm-up. So in the lesson, they start talking about dilation properties. This is what you need to know. You need to know what you are getting. Okay, I'm just going to erase some of this old stuff before I forget. Okay, dilations preserve these things. Measures, though I misspelled that. ES. Parallelism, that means if lines start off parallel, they will stay parallel. Collinearity of points, if 2 points are in the same line, they'll stay in the same line. And orientation, that means things aren't turning. So remember, there's the letter F. Let me do that in a different color. There's the letter F. Now, when I do something like this, I've changed its orientation. It's facing a different direction. Okay? When I do something like this, I've changed the orientation. Everything's not facing the same direction. So dilations preserve orientation. It also creates proportional side lengths, thus needing to know how to deal with proportions. Though this, I want to say book, this program eliminates a lot of the need for the proportions. So next, let's talk about some notation. So this one, they have D of Q comma N. Well, D stands, this whole thing means dilation centered at Q with a scale factor of N. So Q is our center of dilation. Usually that's the origin. The last section in this section, the last part of this section goes off the origin. And our scale factor, which is really a key element to a lot of the problems in here. So slide 3, note that the center, sorry, I cut off mid-sentence there, but I was looking at slide 3 here. I need to go to the red really so I know what to erase. I mentioned Q is the center of dilation. What do I mean by that? Well, you can see I'm on slide 3, right there, slide 3. Center of dilation, that means Q is the center of dilation. As I make the scale factor bigger, notice what's happening to our image P prime. As I make it smaller, geez, notice what happens at 1. Notice what happens when it's less than 1. And so on. So they want you to do that. Make some observations. I'm going to leave it up to you to make those observations. Okay. You will be using some number sense in here. Remember, reduction enlargement. If you're doing a reduction, you should get something smaller. You can use your number sense to, it won't tell you if you got answers right, but it can definitely tell you when you got them wrong and have simple fixes to do. A reduction is when N, our scale factor, remember N is our scale factor, we mentioned that right there, is between 0 and 1. We get an enlargement when N is greater than 1. Now we don't use it a lot in here, But if we use n equals 1, we get n equivalent shape. It ends up being the exact same shape in here. Now, I wrote in here, we need to use this at some point. Image in the green. Image equals n times pre-image. That would be image length equals n times pre-image. That comes from this formula right here, our scale factor. Our scale factor n equals the image over the pre-image. Always has to be like that. It's always image over pre-image if you want to get that right. Now, I got from slide 7, I brought in the diagram from slide 7. I'm not going to show it because it shows you the answer in it. I want to find my scale factor. So n equals q to w, or q to w prime, which is my image, over q to w, which is my pre-image. Now notice I got 5.5 here. Notice how I got that. I need to use this whole segment q to w prime. So I got to add that up on my own. 2 plus 3.5 gives me 5.5. Be careful with that. Please be careful with that. Okay? Now, part 2 of slide 7. Again, I'm using this rule from up here to get this equation. Image equals n times the pre-image. And again, that comes right out of this too. I put in my letters. Q to y prime equals n times qy. I put in the numbers. It's pretty messy. 2.125 equals 2.75 times qy. First off, use a calculator. Don't be afraid of that. You're allowed. Second, just divide. You know what you should divide by here. 2.75, 2.75. Get out your calculator. Calculate it out, see what the answer is. Just because a division is tough to do doesn't mean you shouldn't choose to do it. So that's what calculators are for. Slide 9. They get n equals 1/4. I'm not sure why they're using that instead of the 0.25. They're clearly using some decimals on some of these problems. It's probably just a matter of whatever's most convenient for them without them having explained it. There's a few more in there. The instruction in this section gets a little easier to follow as it goes on, I thought. I've used up most of my time on this video, so I'm going to call it to an end here. Hope you're all doing well today. Get some of this stuff done. Remember, y'all do dilations every single day on your phone at some point. Guarantee it. Until next time, have a good day.